Hey guys, it's Mrs. Saucetta. I'm going to show you how to complete your work for 1116 or 1117 live Zoom. So if you're absent either on 1116 or 1117, you're in the right place. So today it says we're going to learn about potential and kinetic energy. We will review our notes in the digital notebook, and then we're going to do a PhET simulation worksheet is attached here. So the first thing that I want to show you is digital notebook, the new warm-up, and the table of content needs to be filled out. So going to our digital notebook, it's always first thing on classwork. So you need to go to your digital notebook, open up your digital notebook, and you should have already organized your digital notebook. If you didn't organize it yet, then I want you to scroll down and watch this moving your slide video. I just need you to move all your new slides to Unit 2 if you haven't done that yet. So if you have already moved your slides, then you're going to go to Unit 2. To get to Unit 2, you could just scroll down to Unit 2, or you could put your notebook in present mode. And then you could just click on the Unit 2 tab, and it'll take you directly to Unit 2. So the first thing I want you to do is your table of content. Go ahead and pause the screen right now so you can write your table of contents into your digital notebook. Once you're done putting the table of contents into your digital notebook, then you can unpause the video. Now, I want you to notice that the Unit 2 slide is on a slide 11. Table of contents should be your slide 12. That would make your warm-up be slide 13. Your vocab should be slide 14. And then your notes, 15, 16, 17, 18. So we are starting to do our warm-up in our digital notebooks. One warm-up should last you 2 weeks. So make sure that you complete Monday's warm-up. Number 1, energy of motion, is that kinetic, potential, or both? Number 2, what do all forms of energy have in common? A, ability to cause change. B, no possibility to change. Or C, the potential speed of an object. So pause the video, pick your answer, then press play, and I'll show you the new answer, or the answer I'm picking for you. So kinetic energy is the energy of motion. So you should have picked A for Monday. What do all forms of energy have in common? You should have picked A, the ability to cause change in a system. And then we'll do the rest of the warm-ups throughout the next 2 weeks. So once you're done with that, you're going to come down here to our notes. We're going to highlight some important things in our notes. So what is energy? I want you to go ahead and highlight energy is the ability to do work. So your digital notebook will not have the highlights. Your digital notebook will just look like that. And so to highlight something, you need to click and drag your cursor. And then you can go up here and hit the highlight color. So we're highlighting that energy is the ability to do work. You're highlighting that energy is never created or destroyed. You're highlighting that energy can only be stored or transferred. And you can pause the video, and make sure you highlighted the correct things, and then let's move on to the next slide. I want you to highlight where it says the higher an object, the more potential energy. The more mass an object has, the more potential energy it has. So you're going to highlight these. You can pause the video if you need to. And then lastly, you're going to highlight here where it says the greater the mass and speed of an object, the more kinetic energy there will be. Go ahead and make sure you highlight that as well. And you can pause the video if you need to. The last thing is just a diagram. It's showing you a roller coaster ride. I want to explain that a roller coaster ride is considered a system, just like a computer would be considered a system, a bow and arrow or a pendulum could be considered a system. A system is just anything that has components that need to work together. And so within a system, there's a certain amount of energy. And it says the total amount of energy is the same at every location on the track, but the amount of PE, potential energy, and the amounts of kinetic energy are constantly changing. And so up at the very top, that's when you'll have a maximum amount of potential energy, PE max. But you're going to have a very little bit, a minimum of kinetic energy, because this is when you're slowing down, you're not going super fast, but you're very high up, which increases the potential energy. Once you go down the roller coaster and you're at the very bottom, the KE becomes maximum. You're at a high for kinetic energy and a minimum for your potential energy. We're no longer that high up. We're going very quickly, so we have mostly kinetic energy. And then you go up the ride and you'll have your kinetic energy getting lower as your potential energy is increasing because you're getting higher again. So you've highlighted your notes, you filled out your table of content, you did your warm-up, you can exit out of your digital notebook. We're done with that for the day. The next thing, I just want you to listen to me, go over what you missed in class. So what are kinetic and potential energy? So first of all, you just have to understand that energy is everywhere. It's in your batteries, it's in the gas for a car, it's in your car. I mean, the lights, the music that you listen to, those are all types of energy. It's even in your food, and it's even in you and all living organisms. We have energy stored within us. But what is energy? Energy is the ability to do work, the ability to cause change. Everything that happens in the world uses energy. You can't see it, but it's always around you. Really important thing to remember that energy is never created or never destroyed, but it can be stored, transferred, or transformed into another type of energy, but it's never created and it's not destroyed. So when you take a bite of your apple, you're not destroying the apple's energy, you're transferring it into your body. So how is all energy divided? So there's 7 major forms of energy, and they can all be grouped into 2 main categories. Those energies are either potential energy, such as the chemical energy stored in your food, or they're kinetic energies, like electrical energy that travels through wires. It's always moving. So we have like nuclear energy, which is a potential stored energy. It's stored in our atoms. And you have sound energy, which moves throughout the room. It's in motion, so we call it a kinetic energy. So just remember that all energy is divided into these 2 categories, potential or kinetic. So the potential energy is energy stored in an object such as a rubber band, water at the top of a waterfall, a yo-yo in your hand, or a bow and arrow. And I want you to notice or think about the further back you pull your arrow, the more potential energy you're putting into that system. And then once you release it, it has more energy to convert to the kinetic energy. It will go further. Same thing with your rubber band. The further you stretch your rubber band, the more potential energy you're storing in it. So when you let it go, it goes even further. It has more potential energy to convert into the kinetic energy of motion. Some things that you need to be aware of is that the higher an object, the more potential energy it will have. The more mass an object has, the more potential energy it has. So if I have 2 objects in my hands, whichever one's higher would have more potential energy, or whichever one's larger will have more potential energy. So if we're talking about a feather and a brick, the brick would have more potential energy because it has more mass. If we're going to drop something off of a building versus a chair or a crane, the building would give it the most potential energy before you drop it because it's at the highest height. Now, when you're holding the object, before you drop it, it has the potential energy. But right when you drop it, that potential energy starts being converted to kinetic energy. So when stored energy begins to move, the object now transfers from potential energy into kinetic. So when we're talking about kinetic energy, we're talking about the energy of motion. Kinetic means movement. And anything in motion has kinetic energy, whether it's the electricity running through the wires, whether it's an animal running down the side of the street, or if it's a car driving, a marble rolling, a leaf blowing in the wind, anything in motion has kinetic energy. The more mass the object has, the more kinetic energy it has. The faster the object is going, the more kinetic energy it has. So some examples of kinetic energy would be skiing, running, riding your motorcycle, slipping. So when there are two objects moving at the same speed, like a truck or a little car, which one would have more kinetic energy? The truck would have more kinetic energy because it has more mass. An object that has the most kinetic energy when its movement is the greatest. When an object has the least potential energy, it will have the most kinetic energy. So if you're knocking a bottle of water off your desk, when will it have the most kinetic energy? At the top, it's still pretty high, so it has a good amount of potential energy. In the middle of the fall, it still has a good amount of height. But at the bottom of the fall, this is when the bottle is going the fastest. It has the lowest height, which means it has the least potential energy and the most kinetic. So at the bottom of the fall is when you'll have the most kinetic energy in an object. So thinking about a roller coaster ride, when will you have the most potential energy? So you have the most potential energy when you're the highest point, which is at the top of the roller coaster, when you're going the slowest. The higher the object, the more potential energy. So obviously the roller coaster is still moving when it's up at the very top of the roller coaster ride. So there's a little bit of kinetic energy still there, but it has more potential energy. So we could say very high potential energy, very low kinetic energy at that point. So once the train accelerates down the hill, that potential energy is turned into kinetic energy, and at the very bottom of the hill, that's where you have the greatest amount of kinetic energy. If you're talking about the loop-de-loops, when you're at the top of the loop, you'll have the most potential, and when you're at the bottom of the loop, when it's moving the fastest, it has the least potential, that's when it'll have the most kinetic at the very bottom. And so I'm going to show you this animation for roller coasters. So when you first go up that hill, now we have all the energy filled up, right? This is our energy pie graph. This is all potential energy. We're very high up. And then when we come to point 2, we still have a little bit of potential energy, but we're mostly kinetic energy here. Point 3, our potential energy is increasing because the height is increasing when they're going around this loop. At the top of the loop-de-loop, you can see now that there's more red than blue. We have more potential energy than kinetic energy at this point. Then at the bottom of the hill, we're all kinetic energy. At the fastest speed, we have the least potential energy. Step 6, our potential is increasing and our kinetic is decreasing. And so I'm going to hit it on fast play, and I want you to notice that that's the initial energy we put in, and now the pie graph is always filled out. I want you to notice that within the system, the energy is always the same. The total amount of energy is the same within the system, but it's just switching back and forth between the potential and the kinetic energy. So there's only one last thing that we talked about in class, and that was pendulum. So this is a pendulum lab that we used as a demo, and I just want you to notice that when I lift my weight up over on the left side of the screen, you'll notice these bars, right? So these bars are showing us the potential energy and the total energy within the system. So I want you to notice where it went up to right here. But what if I change the mass? How does that affect potential energy? So I'm going to make my mass very small, and we're still looking over here at the left at that graph. So you'll see that my potential energy bar and my total energy bar are very small.